Hello friends, today I'll be discussing with you question number 10 of GATE Physics 2017. Now the question is like this: if the Lagrangian L0 is equal to half m dq by dt whole square minus half m omega square q square is modified to L equals to L0 plus alpha q dq by dt, then which one of the following is true? So option A is both the canonical momentum and equation of motion do not change. Option B is canonical momentum changes, equation of motion does not change. Option C is canonical momentum does not change, equation of motion changes. Option D is both the canonical momentum and equation of motion change. Now let us have a look at the solution to this question. Now we are given two Lagrangian L0 and this L, where this L0 is the original one and this L is the changed Lagrangian. Now we know that dq by dt can be written as q dot, and therefore my L0 reduces to this expression and my L reduces to this expression. Now we can find out the canonical momentum P by using the Lagrangian formulation. So my P is given as delta L by delta Q dot. So for this L naught, my canonical momentum P becomes delta L naught by delta Q dot. So I can find out this P by differentiating this L naught with respect to Q dot. So by differentiating this L naught with respect to Q dot, I see that it becomes half m 2 q dot minus 0, because we don't have a q dot over here. So the canonical momentum P for this Lagrangian L naught comes out as m q dot. Similarly, if I do it for this L, then I find that my P for this L comes out as m q dot plus alpha q. So we have q dot over here and we have q dot over here. So these two terms come in the differentiation and this term becomes 0. So my canonical momentum P for L naught is m q dot, whereas the canonical momentum P for this L is m q dot plus alpha q. So we have this extra term in this L. So the canonical momentum changes because of this extra term over here. Now let us see what happens to the equation of motion for the changed Lagrangian. Now we know that from Lagrangian formulation, the equation of motion is given by d dt of delta L by delta q dot minus delta L divided by delta q equals to 0, and therefore for L naught, this is my equation of motion. Now we have already found out this quantity when we found out the canonical momentum. So delta L naught divided by delta q dot, we got m q dot. Now we can find out this term by differentiating this with respect to t once. So by differentiating this with respect to t, I get m q double dot. Now to get this second term, I have to differentiate this L naught with respect to q. So when I differentiate this L naught with respect to q, so this first term vanishes because we don't have any q over here, and only contribution comes from this second term. So differentiation of this gives me minus half m omega square into 2q, and half and 2 goes, so I am left with minus m omega square q. So the differentiation of this term gives me minus m omega square q, and we have a negative sign over here, so minus minus becomes plus, and therefore the equation of motion for this L naught becomes m q double dot plus m omega square q equals to 0, and m cancels, so the equation becomes q double dot plus omega square q equals to 0. So this is the expression for the equation of motion for this L naught. Now let us see what is the equation of motion for L. So for this Lagrangian, the equation of motion looks like this. So we have found out this quantity delta L by delta q dot we have already obtained, and that was m q dot plus alpha q. So we can get this first term by differentiating this with respect to t once. So I differentiate that, so I get m q double dot plus alpha q dot. So the first term is this. Now again we can obtain this second term by differentiating this L with respect to q. So if I differentiate this L with respect to q, then this term becomes 0 because we don't have any q over here. So the only contribution will come from this and this. So differentiating this with respect to q and this one, I get minus m omega square q plus alpha q dot, and putting this and this value into this equation, I get this expression. And we can see that we can cancel out this alpha q dot and this alpha q dot. So I am left with m q double dot plus m omega square q equals to 0, and again m cancels. So we are left with q double dot plus omega square q equals to 0. So we can see that earlier this was the equation, q double dot plus omega square q equals to 0, and for the changed Lagrangian again we get the same equation, q double dot plus omega square q equals to 0. So the equation of motion does not change for the change in Lagrangian. So we can see that the canonical momentum changes, but the equation of motion remains the same. And if we look into the options, then the correct option is this option B. Canonical momentum changes, equation of motion does not change. So that is it. Thank you.